So unlike lots of lab scale CIPs that you might have, that you may have seen from other vendors, which they're pressing from the top like this, so your piston is driving kind of like what you have with uniaxial pressing, but it's got an O-ring on it, and that piston drives into a hydraulic fluid. So there's two problems with that. One is your piston is moving, so it's called dynamic sealing, so that wears out your O-rings. And so that means the O-rings become a consumable that you're working through quite often, and you're having to play around with it. As you may have seen from those, you get rubber that's kind of extruded up into the gap behind your piston. So there's one part, and the other part is that the maximum pressure that you can get to is limited by the orifice size, the size of the hole that you put your sample in, and also the size of the press you have. So if you want to do a large sample, a large diameter sample, then in order to get to high pressures, you're going to need a really big press. And if you, otherwise you're just going to be limited by the size of the hole that you've got here, or the size of the press that you've got. It's a square rule. So as your sample gets twice as big, you're going to need a 4 times the size of press. So it very quickly gets unwieldy, where you'd need a 100-ton press in order to press something that's, say, a 2-inch diameter. Whereas for us, for our patent pending design that we've made, which is really what makes this a game changer in powder pressing at the lab scale for us and for many others, is now that these two things are separated, your pump is separate from your chamber. You can have any size hole at the top of your chamber up here, and you're not going to be limited by the size of the press you have. You don't need a separate hydraulic press, so you don't need a 100-ton or a 50-ton or a 40-ton press in order to work with this. You can use this standalone as it is, and as you can see, it's small and it's compact and it's lightweight. You can pick this up and take it wherever you need to go. If you're doing work at the synchrotron or wherever you're going, you don't need to haul a 200-kilo press with you. So just to talk to you a little bit about the CIP, this is the chamber itself. You've got 2 main parts, simple but very effective design. You've got your enclosure lid here, which has one part of the sealing, and then you've got inside of here, you've got the second part of the sealing. So you need both parts of the seal. When this is fully engaged into this thread, those two meet, and that's what creates a really good ultra high pressure seal. If you do need other O-rings, they can be supplied to you, you can just contact us. So inside of here, this is the MESO CIP. It's got a 38mm diameter hole for the sample. This is a bit larger that takes the thread, and you can and that will have oil in there when everything's connected. So when it goes in, you just wind this all the way down, and then you'll start to feel a little bit of resistance when they're engaging. You then just keep turning it, and it could be that at the end of this turn, if you've got a very large one of these or you're struggling, there it's fully engaged. Once that's in, that's sealed. What we like to do, just to make sure, is this is hardened steel, you're not going to hurt this if you're using a rubber mallet. Just give it a couple of taps around just to make sure that you're fully engaged, and then you're ready to press.